My name is Farzaneh Khorsandi, and I'm assistant professor in an extension specialist in agricultural safety and health, the Department of Biological and Agricultural Engineering at UC Davis. And my main focus is on farm workers' safety and health. And as I mentioned in the beginning of this session, agriculture is one of the most dangerous industries in the United States. And since I started my position, I noticed that majority of conferences and events related to agriculture, majority of them just focus on improving the quality and quantity of the crops, and almost no attention to the safety and health of farm workers. And I appreciate Erwin to invite me to have this session here and bring this important topic to your attention. And in our session, we had different discussion about Fadi talked about musculoskeletal disorders and their intervention to improve the safety and health of the farm workers. And Pauline and Jennifer provide some information about the available vehicles and machineries that they use on farms right now. I'm going to have very short talk about new technologies that we have are in the research level and in commercial level right now for harvesting leafy greens, specifically for harvesting leafy greens. And then we're going to go to the roundtable discussion. This is, let me see. This is, for harvesting leafy greens in general, things that, I search online and find, different device vehicles, for harvesting them. And majority of them has, pretty similar mechanism for work. And majority of them have some kind of header that it protects the plant, bring them in a row, or if they are falling on the ground, they bring them up. Then there is some kind of blade. It can be in one of them you can see that it's a water jet or some kind of blade to cut the plant. And then there is a conveyor that usually brings it to the platform for a further process. And this is one of the examples of the device that designed by a company in I think it's in California. Ortomec, the name of the company is this. And it has different setups for harvesting different types of leafy greens. And one of them that you can see in this photo, it's it use band blade to for harvesting high density crops, and it can cut the crops from 1/2 inch from the bed top. And as you can see in two examples of them, it needs 2 to 3 operators, and one of them control the vehicle and the other one do the handling of the process. And the speed can be between 5 to 5 miles per hour, and the harvest speed is up to 3 miles per hour. And we have, pretty similar mechanism for harvesting lettuce, the same company. And we can see that, it has a longer belt conveyor, and in addition to the very short platform that the previous one had, this one has a longer platform for further processing, packing, and other stuff. And for this one, there is one driver for the tractor and 6 to 8 persons to complete the task. And there is another one that Jennifer showed in her presentation, and this one uses the water jet to cut the plants, and the efficiency of this vehicle is about 6 to 1,000 pounds per man hour. And as you can see, there is one operator for riding and controlling the machine, and between this one is dead, but between 6 to 4 person for handling for packing or handling the plants. And this is another one that in addition to the harvester by itself, they have camera, image processing techniques, camera and pattern recognition. and they can, uh, detect the foreign objects like, a piece of plastic, bird droppings, and other stuff on the plant. And if they detect any kind of disease or, damage on the plant, the device by itself has some kind of arm that push the plants out of the harvester way and doesn't let the damaged plant to go inside the, the vehicle. And this is, a cabbage harvester. I searched, for different vehicles, and I noticed that, they have pretty similar mechanism. They have a blade for cutting the cabbage, then some kind of, belt conveyor that send it to a processing plant, the processing stage. That there are, as you can see, there are some, people or farm workers that, do the further process and then, drop it to the bin. And, for this one, they use, this device, this vehicle. There is one person for operating the machine and 3% to handle the crops in the of the vehicle. And we have fennel harvester, and pretty the same mechanism that, it has again, some conveyors, some blades for cutting the plant, and the machine capacity is about 2 to 4 ton per hour. And there is a person again for operating a machine and person to handle the crop on the machine. And the only difference that this machine has with what Jennifer showed is that we don't have a lot of workers walking around the machine. A majority of them are just either one of them operating the vehicle, and the other ones they are standing on the platform of the machine, and they do not walk around the machine. And in addition to those machines, we have also farm robots. And in general, we divide the farm robots into 4 groups. The first group are collaborative robots. We're going to have Stavros, one of our colleagues, that developed these, collaborative robots. That this is, the very early stage design. Fadi already showed this one. They developed a newer version of these collaborative robots that this helped the strawberry pickers to transfer the picked strawberries to the storage. There are some other types, we call them coexisting robot or mobile robots, that they work in the same place with the farm workers, as you can see in this photo. And there is other type of robots, wearable robots. This is an example of wearable robots that empower the farmers to do different tasks. This is a specific one that developed in Tokyo University of Agriculture. And their main focus was on older farm workers, and their plan was to give them the ability to continue farm works. There are other types, drones. One of the example is the drone that they use it for pesticide application, and the other ones are self-driving tractors. And there are some robots or fully autonomous vehicles for harvesting the leafy greens. Most of them are in the research stage. I just bring some of them as example. For example, this asparagus robotic harvester, it has 3 components. The first one is a vision sensor that detect and locate the asparagus, then an robotic arm, and also the driving mechanism. Pretty similar mechanism that used for harvesting lettuce. As you can see, they have a camera to detect the lettuce and also locate the lettuce and see, whether they are ready to be harvested or not. They use different techniques for harvesting lettuce. One of them was using two arms. One of the arms was for holding the lettuce, and the other one had a knife for cutting the lettuce. Next one was using a rotary cutter, and the next one was some kind of blade for cutting the one arm blade for cutting the lettuce, and the last one was using the pneumatic cutter. And they picked the pneumatic cutter because it has a better output. And this is an example of autonomous lettuce harvester, which is in the research level. And this is another example of the arm for harvesting cauliflower. And again, it has pretty similar mechanism and previous ones, that it approximate the location of the cauliflower, localize it, and then grab it and cut the cauliflower. And this is some examples of robots that can be used on farms. And the type of interactions that human going to have is very different from working alongside with the vehicles, and it will be just for example supervising robots doing different tasks. And with this one, I'm going to invite the committee to come here, and we will be happy to answer your questions.